All right, so play a little video. We had our folks. So I spent some time overseas in Okinawa, Japan, as a commander and DO, director of operations of an AWACS unit. And one thing I noticed that both there and at Thumb Rate in Tent City, flying missions over Afghanistan, that wanted an opportunity to be able to just get our message out in more than just small groups. So this is a video that we're putting on the AFN. So I'm torturing the people out in Okinawa and anywhere overseas. Those of you who haven't lived overseas, what happens is that you don't get commercials on Armed Forces Network. You get Air Force, Navy, Army commercials, and so this will just add to those commercials. It's Okinawa. We had this great styrofoam cup recycling commercial, so hopefully they replace that one with this one. So we'll just go ahead and start.
We depend on our airmen to keep us safe. They depend on fuel to fly, fight, and win. Whether they're conducting airstrikes, delivering cargo, transporting our troops, or saving lives, airmen need fuel to complete the mission. But we need to be smart about the way we use our resources and ensure the fuel is there when and where airmen need it. At Air Force Operational Energy, our goal is to create an energy-optimized force that maximizes combat capability for the warfighter. Through innovative technologies, data analysis, and an energy-informed culture, we can streamline operations, reduce aircraft drag, and ensure a ready and resilient force. Being smart with our operational energy allows us to increase range, fund more training, lower sustainment costs, increase readiness, and fuel more fight. Will you join the mission?
Those of you who were here for the last lecture, this is the Department of Defense operational energy definition. On the right is obviously a 5th gen fighter doing some air refueling, or excuse me, on the left, and then on the right is some of the challenges in some countries that we operate with respect to fuel logistics and other types of logistics. Our office was stood up in 2010 as a result of the operational energy office that was stood up in the Department of Defense. And that office was stood up in direct, well, it was stood up because we were seeing in theater is that I think it was either 2007 or 2008, about 30% of the casualties were not in combat, but they were in delivering supplies to forward operating bases. And the DoD said we need to start looking at what's going on in those forward operating bases, what kind of generators we have, what kind of power we're pulling. So water and fuel going to those forward operating bases were resulting in a lot of additional casualties. And so as the Army stood up their office, we came in because we burn a lot of fuel, and we'll talk about that. So that amount of fuel that we burn is it's an asset, that we can operate that many airplanes, but it's also a vulnerability. And so when I think about what my office really does, it's a lot about this. In the theaters that we operate in, unlike now, where we operate in the Middle East, where the oil is extracted and produced on site and is very cheap and easy to get to, these are going to be huge challenges. So this is just the pipelines in Europe. So you can see that pretty much things stop at the East Germany, West Germany border. So when you plan out any kind of operations there, you're going to have to deal with that type of challenge of how you're going to get forces and equipment to the east of the East Germany, West Germany border as it's planned right now. What kind of decisions are we going to make with respect to infrastructure and with respect to other types of things that we're going to need in order to execute a mission well. And this is a huge challenge. And we just kind of put some different arrows up there to discuss the challenges between, a permissive and non-permissive environment in the South China Sea and what kind of challenges we're going to deal with there. So when I look at operational energy, I think about these challenges and how we're going to go after these challenges. And we really look at it in three main areas. That is, we look at what we call current operations. So we want to take a look at the data that we're collecting right now, which is very minimal, by the way. We don't collect as much data as we should in the aircraft that we fly. And then as a former pilot, I know that there are times that we would do stuff that just didn't make sense. But that's the orders I was given. As a squadron commander, you got a 1,200-hour flying hour program, and I'm going to fly those 1,200 hours whether I'm going to get good training on September 29th and 30th or not. And so why are we doing that? And who's identifying that that money could be repurposed somewhere else to use it towards combat capability that's currently not happening? So the current operations piece, a lot of that, we look into data collection. I'll talk about that in a little bit. The second piece we look at is what we call future operations. So that's looking at legacy aircraft because, as I'm sure most of you know, Air Force is going to be flying some of these jets for a long time to come. F-16s are going to fly to the mid-40s. B-52s are going to fly to the mid-50s, as it's currently planned right now. KC-135s. Say again?
Like 2150.
Yeah, it feels like that. Yeah. So, and then, we're going to keep KC-135s around for probably another 25 years as well. So with that, we look at legacy aircraft to see, what technologies are out there that are being used already in industry that we have somehow forgotten about with some of these legacy aircraft. Winglets, other drag reduction devices, engine improvements, those type of things. Then we also advocate for, although I don't receive as much funding on really pushing big Air Force acquisition systems, I do spend time advocating for big acquisition systems that are going to support operational energy initiatives. For example, would be, hybrid wing body tankers and hybrid wing body aircraft, where you have a technology that has been proposed that could give you about 40% extra fuel, or at least 40% better fuel burn, or 40% more range just by changing the design of an aircraft. And so we look at those type of things and figure out how to bring them across the finish line. And then the final piece that we look at heavily is aircraft logistics and sustainment, as well as wargaming and how we wargame fuel in operational plans that we're testing out. How do we do it jointly? And so I'll discuss a little bit about that too, because I was surprised at some of the answers I got from other leaders, to include senior leaders in the Air Force, about where we were going. And really what we found out is as we stood up our office and we started to build up capability and we started to show what kind of services we could provide to the Air Force, we found that people were more than willing to accept our help as long as we brought money and manpower. If I was asking a major command outside of Air Mobility Command to stand up a fuel efficiency office, they, at that time, they were having manpower cuts. So they were like, I'm out of schlitz. I got to just figure out how to keep my readiness at a certain point. I can't give you extra folks to figure out how to tackle this fuel problem. So, okay.
Just one real quick question on that slide.
Sure.
Go back.
Yep.
So, one of the things in Europe, in particular Eastern Europe too, there's all kinds of pipelines being built right now. Some of them are under control of Russia. Some of them are under control of some private organizations. But when I look at these pipelines, the question that comes to my mind is, who is competing for fuel with these pipelines? So, for instance, if there's an all-out war in say in Europe, and you need fuel, are there, this to me looks like France and Germany get their first dibs on that fuel before the U.S. Is there any sort of prioritization at maybe a NATO level that says, okay, here's how we're going to distribute and allocate fuel, because I'm sure there's not enough pipelines in there to handle all the fuel you're going to need.
Yeah, so that part, I couldn't tell you for sure. I know that we're having discussions. I've traveled to Lithuania a couple times. Their Energy Security Center of Excellence is in Lithuania, and that's part of the discussion that's happening now. How are we going to go about prioritizing? How do we analyze this? We had a set of folks that the Air Force paid a lot of money to come in and tell us how to prioritize where we're going to base, right? Where we're going to base our aircraft, based off of what available resources were inside the fence line. And I was a little surprised. I said, really? Just inside the fence line? So if there's tanks off base 5 miles that we're going to go protect because we need those tanks, did you guys not consider that? No, we didn't. So it's just a more thorough understanding of the ecosystem that's really not happened up until now. And that's the part that we're starting to get to just internally in the DoD. So I can tell you that in our wargaming, the Air Force has done wargaming to look at the Pacific, but really the first time that we looked at fuel, I heard a senior leader once say that we would drive a C-5 in fairy dust logistics. That was the first move in the war game before we actually went after the rest of the war game. And now we're starting to, at least on the Air Force side, play it much more realistically. Not just inside the fence line at that one particular base, but as well as how we're going to get fuel from other services. However, the Navy and us just this summer, in July, we're going to be doing a joint OE war game where we're going to play that out a lot more realistically. I'll talk about the wargaming piece of it, but that's just internally within the DoD, we haven't done what we feel is the level of fidelity to really inform our investment decisions. Okay, so the office stood up in 2010. I showed up in 2014. I only had one aviation person, and since then, through just my connections within the Air Force and a discussion about how important this is, we've built it up to the point where I've got 3 GS-14 civilians, a GS-15 who's a director of staff for me, as well as some pretty robust contract support to look at data analytics, to look at strategic communications, because that's what this part is really. What I'm trying to do is help everyone understand what the challenges are that we're currently working on. Hopefully, I can tell you for sure, and I had an old commander used to say this, I'm 100% sure we're not 100% right on what our goals are and what we're going after. We have an idea of what we think is important, but we need those of you who are coming up in the ranks to help inform us on both sides, on the Navy and the Air Force for the Pacific fight. That's going to have to be a joint fight where we're going to have to understand how we're going to execute that war game, execute that operational plan, and that really takes young leaders like yourselves who are going to move up in ranks to start prioritizing that as part of the way we execute the mission. Okay, so, and I'll tell you that bumper sticker is just that, when I initially started this office and started going to major commands, with the operations portion of the major commands, A3, I had senior leaders tell me, well, you're just trying to take my flying hour program. That's what you're going after. You're just looking to save fuel. And what we're really looking at is how do we increase combat capability, how we repurpose those savings when realized into other things without affecting readiness, without affecting the way the mission's currently being done. And we can easily do that. And we have some examples in here of just initial looks at this problem and what kind of solutions we found. And I'll tell you that the bottom line is that if you're not collecting the data, then you really don't know what's going on. And so you can assume that something's happening in a certain way. And in a couple cases, we've found data and gone back to the owners of that data and said, look, what's going on? And they're changing their behavior because they realize it's not only that they're burning more fuel, but they're actually hurting readiness from aircraft maintenance perspective. So, okay, so we put that up there because we want people to understand that I'm not about the fuel. I'm not about just saving fuel. I mean, it's a byproduct of what we do, but in many processes that we have in the Air Force right now that are 19th century processes that are transitioning into 20th century processes, we need to bring them into the 21st century. We need to be able to compete against peer competitors, and that means that we need to start thinking differently than we have in the past. So I visited an aerial port not too long ago, and that was part of a visit to Charleston Air Force Base, and these guys were great, and we had a good time talking about what their mission was, but it took me a little while to crack through this is good enough. What we have is good enough. And explaining that what we have is good enough for the current fight that we have right now. But we will not be able to maintain the levels that we need to level against a peer competitor if we just say this is good enough. Like, okay, I'm going to deliver, I've built up a chalk, I've got a pallet, I've got to go out and print, the printer's on the other side of the hangar, I'm going to go down, it's like, boy, I go to Enterprise Rent-A-Car and those guys print out a label right on their waste and boom, it's on the package and it's going in the next direction. So that kind of thought process needs to happen. They had an auto plan function for how they load a C-17, didn't work right, so they don't use it. And in their mind, it's okay because my level right now of how much stuff I have to load on planes and ship overseas is not that much, so this is fine. But we had to stop and say, guys, you don't understand. Guys and gals, we are here to find out your problems and help us figure out solutions for you. And so in a lot of processes that we have right now, it's like, this is okay, it's working fine, and it's not thinking about, we're in a race, and to compete, we have to be thinking through how inefficient our processes are right now, and it might be okay right now, but it's not going to be okay for the future fight. So when I look at this is kind of, for me, my target of potential transition to more combat capability. That's actually kind of a low number because gas prices have been have gone down, but they're starting to climb back up again. I'll tell you that the Air Force manages its fuel budgets in a centralized manner. And that's part of what we're trying to work with. So what I mean by that is that the FM at the headquarters assigns flying hour programs to MAJCOMs that they execute, but nobody's looking at how much fuel they're burning with respect to that. So they're not incentivized at the wing level to stop flying on September 29th and give that money into something else. They're not incentivized to invest in technologies that would get us, even cheap technologies that are quick payback. They're not invested or not incentivized to do that because they don't get any payback from it. So what we're trying to do is rethink, we centralized fuel counts in the Air Force because we saw at the wing level that we were making investments that just didn't make sense from a big picture. Investments that weren't about readiness. And I could give you some examples, but but I won't. I'll just say that if you can think about an investment that a wing commander might make that doesn't go directly to readiness, that was happening, and when the FM saw it, they said, hey, we need to tighten this up. So let's centralize the fuel counts. And now we're kind of in the other end. So these, type of investments that weren't really combat capability are gone now. But now what we're doing with that money is instead of putting it towards combat capability in different types of technologies to make us into the 21st century or bring us into the 21st century, we're burning it out tailpipes of aircraft. So that money is really still not going to where it needs to go. And so we're actively working with our FM to devise a strategy that helps identify the waste and incentivize reducing the waste by either giving back some of the savings to those wings that can use it towards combat capability or giving it to the MAJCOMs by way of procurement money that'll go after winglets and these things called microvanes that I'll show us that we've developed that are just waiting in the wings for someone to say, yep, we're going to do this and we're going to put money against it and we're going to save the Air Force some money and fuel. That'll be repurposed somewhere else. And you can see this is the big bumper sticker. Almost 60% of all DoD energy use is Air Force operational energy. So all the tanks, all the ships, all the Navy and Marine Corps and Army helicopters, all those added up still are only about 42% of the overall budget. So we've got a big target. That's been up to $10 billion in the past. So you can think just a few percentage points off of that, which is totally doable every year. It's totally doable. We talked to FedEx, UPS, and they've given us their strategies and how they've been able to use 21st century technologies to bring their usage down. That could be a huge potential boon for us to use that money to go back into other technologies that I'm going to talk about here in the future, or in a couple seconds. Okay, so what we did last year is with the release of the National Defense Strategy, we wanted to make sure, right after this, the Secretary of the Air Force put out her priorities. We wanted to make sure, yeah.
Sorry, sir. That percentage, does that also include AMC, like C5s and C17s? Are you including that in there as well, or is that just Air Forces?
No, that's going to be all. So yeah, so some TWICF funding for things that we do for other folks, that's included in this. So if the Army buys a C5 or a C17, that's part of our 58%. Yeah, but still, that's still, you know, a couple percentage points off of that, that's still a big bill. We burn about $1 billion of fuel in C-17 every year, about $750 million in the KC-135. So you got a couple targets there that if you just bring in 21st century technologies, all of a sudden you have money that can be, you know, you have cost avoidance that can be repurposed somewhere else, you know, to increase combat capability. So, so what we did is we wanted to make sure that our goals are aligned to these, you know, because it's, you know, if you're not aligning your goals to what your boss's goals are, there's a disconnect there, and you're not going to get much support for them. So we looked at these 5 areas, and what I'm going to do is I'll go through each one of these and give you some examples of things that we're looking at. Now, like I said, we don't have all the answers, so we're looking for folks to come with us with things to study and ideas of things that, technologies that we may not know about that we could adopt and fund. We get, depending on the year, we get a certain amount of congressional ad money. It has been as high as $35 million in the past. And we've been using that congressional ad money to go after these type of technologies that we know are out there that we're just not using in the Air Force. And we're not using them because there's always something that's a little bit more important. You know, that flight data recorder is important, but it's not as important as the next small diameter bomb or the next missile or something like that. And so often, these things that we really need to be able to do good operational analysis are not there, and because of that, we're not seeing those things that we can improve. Like, you know, you go to the airlines, they collect everything. You know, at FedEx, UPS, they collect everything. And they were able to identify this past year, just in predictive maintenance, I think Delta told us that they were saving around 270, they went 270 days without a maintenance cancel on their flight line, 270 days. And that's something that's fairly new through predictive maintenance. That type of stuff for us is combat capability. So I'll show an example where something that we're doing is actually hurting us, and we've made some progress towards having those folks, now that they're looking at the numbers, go, wow, maybe I can do that in another way that'll actually continue my training, but it'll keep me from having more maintenance done on our aircraft. Okay, a couple of you have seen some of this, but so we're developing this Air Force-wide data collection effort with fuel. Those of you who don't know, the Air Force stood up a Chief Data Office about a year and a half ago now. And that Chief Data Office has been setting policy and trying to devise a strategy for how we build a lake and how we mandate data collection on our weapon systems. And so what we've done is we've started digging into each weapon system, each aviation weapon system, F-16s, C-17s, KC-135s, and we're trying to narrow down what the gaps are in funding. I can tell you right now, the F-16s, 5% of the F-16s, that's 950 some odd F-16s, 5% of them have a 20th century flight data recorder, 20th to 21st century flight data recorder that can actually capture, you know, on the order of 50 some odd hours of flight data, right? And that flight data is useful to us to look at how the execution of the mission's going. It's also useful to safety because right now, the other 95% have flight data recorders that collect somewhere between 15 and 30 minutes of flight. So that's basically reactive safety. Plane crashes, I have a flight data recorder, let me figure out what goes on. As opposed to proactive safety, which is we see all these events that are going on, let's figure out why these events are happening, and let's see if we can prevent them. And then in the same way with maintenance, it's that type of data collection on these 1980s vintage 15 to 30 minute flight data recorders is really not helpful for our maintenance folks to be able to figure out and do predictive maintenance like we're seeing in the commercial airlines. And like I'm sure our adversaries are going to be doing any minute now, so why aren't we doing it too? Teaming up with combatant and major commands to optimize flying operations. So we've seen, and there's a little example, we've seen that, you know, the whiteboard is just not the solution anymore, and it hasn't been for a long time. The whiteboard is like a 19th century chalkboard that's just a little glorified. So we'll talk about what we're doing there. Because this piece is really about planning and execution. You know, when I visit a B-52 wing and I talk to them about their operations and they bring out a slipstick as one of their things that they take out to the jet every day, you know, which is a slide rule, I kind of, you know, I get that has to be there, but other pieces of mission planning equipment that aren't there right now don't get funded because there always seems to be a bigger priority that really hurts us in our ability to be reactive and quickly re-mission plan when you're out on the flight line. Analyzing mission operations and recommended optimized processes and policies. Develop strategies to incentivize efficient mission execution. This is the last part that I talked about just earlier. We have centralized fuel accounts, what types of working capital funds and other ways can we set up where if I can't get a MAGCOM to study this on their own, how can I fund someone going in and studying it for them and helping us bring down the costs of operation and increasing readiness for our aircraft and crews. All right, so here's a couple of examples. I guess 4 of you have seen this before, and the rest of you probably haven't. So as an AWACS guy, when I would fly, I would typically get a certain fuel load the night beforehand. We would do our mission planning and we would determine how much extra fuel we needed to conduct that mission that day. We'd typically have an air refueling plan somewhere in there, and depending on how much activity we had, we'd have a standard ramp load that was on the low side, and then we would add more fuel the night before to whatever the weather was like for the next day and whatever the mission was that we were required to do. And so this is an example. It's actually actual data from one airframe, and the red line is, and this is kind of like a histogram of, kind of the percentage of landing weights you should see in this aircraft depending on just how often it's going to happen and depending on the mission. That red line is min fuel, so I have to get back and land before my engines run out of fuel. So that's a basic part of mission planning. The green line is as you go through your mission planning, there are going to be some missions where you're going to have to add fuel up to that amount because you need to divert. You don't know if the weather's going to be so bad that you can't land at that one airfield that day. So with this, we took a look at the missions that were being conducted, and we found that our analysis said that the majority of the missions are going to be in this range. Some of this is a little misleading. It's actually a little bit shifted over, but that a lot of missions, because of the weather at that particular place, a lot of missions are going to be landing within these two lines. This little bump right here is so we fly old planes, so sometimes you have to do what we call an engine running crew change, where you're going to land with a fuel load, and you're going to use that extra fuel to run the engines, offload one crew, onload another crew without shutting down anything, and so you don't break, and then get back airborne. So we knew that was like about, 8% I think of the missions, roughly 8 to 9% of their missions. So we were trying to take into account everything that they do on a normal basis in their training mission at this one particular base. So this is actually what we saw, which said their average landing weight is about, 25,000 pounds over what you would think it would be. So initially we went in and said, hey, this is a problem. And they acknowledged it. Initially it was difficult to get the data because it turns out at the organizational level, at the wing level in the Air Force, we actually have this thing called AFTO 781, which is kind of the forms for all our maintenance. The 781H form collects fuel usage and oil usage, and in looking at that, we were able to take 60 days worth of data. When we just visited there, we said, hey, we're brand new to the Air Force. We'd like to look at what you're doing and see if we can help you optimize your missions. And unfortunately, they only had 60 days worth of data for us to look at. And we're like, where's the rest of it? And well, we shredded after 60 days because the maintenance requirement is not really there to keep it past 60 days. It doesn't make it into the maintenance database or record. There are other things that make it in the maintenance database or record that are held for years and years and years, but those particular forms are not. So after about a year, we discovered that they actually have a separate form that the aircrew fill out. They don't hand to maintenance. They hand it to the folks who deal with what they call the Aircraft Structural Integrity Program. So a separate process where that form doesn't stay within the wing, but it actually gets delivered to an office in AFMC, Air Force Materiel Command. And those folks are actually looking at what kind of weights these aircraft are being flown at. And that data is kept for a long period of time. Well, since the operators at the organizational level didn't know about it, it took us a while to actually get that data stream. So initially we saw this, we said, wow, that's a problem. We got 60 days worth that turned into 1 year's worth. That when we actually talked to the structural integrity guys, they said, yep, we got 10 years worth, but it still looked like this. So for the last 10 years, this has been kind of the standard operating procedure that they've had there. Yep.
Is this full stop data?
Yes. Yeah. 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 So, you know, as an AWACS guy, I tell you that I would sometimes, maybe the weather was kind of skosh, so I'd be coming back towards that 40. And weather turned out to be actually better than planned, and I'd just beat up the pattern and get all my crews upgraded on their touch and goes. And so I would typically land pretty close to that 20. You know, in AWACS fuel. AWACS fuel, I think, was like 16 was our, or 12 was our low fuel lights. So, okay, so this was our first kind of use case where we said, hey, we have a minimum amount of data, let's see what we can do with it. I've got a guy who is part of our contract team who has got his PhD in energy economics from Duke, so he's a pretty smart guy. He was able to calculate how much fuel we're burning to carry that additional fuel. Roughly, it's about 3% penalty. So if you carry, I don't know, 1,000 pounds of fuel for every hour you're flying 1,000 pounds of fuel, math in public, 30 pounds, 8-hour mission, about 240 pounds. So it could add up, right? And in this case, this one particular type of aircraft burns only about 3% of that total fuel burn for the Air Force. So 3% of that 5 billion is in this one type of aircraft. And they were burning about 7 billion out the tailpipes of their aircraft just to carry that extra fuel that they're never going to use, right? So that didn't really resonate with the wing leadership, though. They said, got it, but no one's really incentivizing us to behave differently. And you have to understand that, you know, I have issues getting exact fuel loads to all my jets. And since nobody's paying me for the extra maintainers and fuelies and that kind of stuff, I'm probably not going to change my process too much. And I understand that, and that's where we're trying to look at processes like this where gas is O&M money, you know, extra contracted fuel truck drivers, extra maintainers to help fuel aircraft is O&M money. Maybe I can shift some of that money. I guarantee you in these particular cases, it would be less than $1 million that I could save $6 million to be repurposed somewhere else as opposed to burning out the tailpipes of aircraft. But the second part is that we said, okay, we can't help you with that right now. Maybe we'll get to you next year after we have this arrangement of a working capital fund. But what else can we do to convince you to stop doing this? And in talking with my team, we said, well, they're going to care about readiness. They're going to care about, you know, does that type of behavior cause any additional maintenance on landing gear, tires, struts, brakes, and that kind of stuff. So let's just look at that. And that's one thing that the Air Force has is a wealth of knowledge on, you know, when you take a work unit code for a particular type of asset, you can go back and figure out per tail how much work's been done on that particular aircraft and come back and say, this is how many extra hours of maintenance you're doing, this is how much extra with respect to parts. So when we dug into that, we found that one particular asset had about 350 hours per aircraft per year of extra maintenance done just to replace the tires, the brakes, and to service the struts. So what we're not looking at is we weren't looking at any engine issues that might be as a result of flying extra heavy, and I'll talk about that in a sec, as well as we didn't look at any other airframe issues outside of the landing gear itself. And so we figured that was about almost $2 million per year extra cost in parts, right? And so that's starting to resonate with the wings, because now you're telling them, hey, not only are you burning extra fuel that is not good for us, but your landing gear at jets broke, which is not good for your readiness. And if you multiply it by the number of aircraft that they had at that one wing that we looked at, it's about 7,000 hours of extra maintenance done on their aircraft just to deal with the fact that they're flying heavier than they should be. You know, and so that's starting to get some momentum, because we're big on readiness right now. We're talking about how do we reduce readiness. And I wanted to give you this because when you look at all the various airframes that we've looked at, we've really looked at only one aircraft at the top that has that 3 to 4%. All these other airframes we haven't spent as much time looking at, but we know that the same type of behavior exists because when we look big picture, we can see the landing weights of some of these other airframes. Air Mobility Command is pretty good at helping us with that, and you can see that that type of behavior exists throughout because nobody values right now the extra fuel being burnt and the cost to carry that we need to start valuing. Okay, let's see, I want to make sure I'm not missing anything. I think I was going to talk a little bit about what we did find as well when we did this. I've got a separate chart that I didn't want to show, but it's basically we were able to buy aircraft, say this is how much cumulative extra weight this aircraft has carried over this 10-year span. And then by aircraft, look at all the additional maintenance actions on gear and parts, and that's where we got that 350. We actually got a curve, and it starts on one side, and it basically, here's the aircraft that were landed efficiently, and here's the aircraft that were not landed efficiently, and then here's the number of maintenance actions that we had per this landing weight, and that gave us a pretty good curve, which helped us say, yep, we're pretty sure that this is, I think we had a 95% correlation that those numbers were truthful. And what we also saw is that max landing weight, this one particular aircraft is 100,000 pounds. And we saw a lot of dots at 100,000 pounds, and we're like, what's going on? So let's take a look at that. Well, it turns out that because of the way they did business, standard ramp load, I'm going to take off with whatever I have. They were coming back to the airfield. They'd get their mission done. It was shorter than the normal mission. They knew it was going to be shorter than the normal mission, but that one particular aircraft is difficult to defuel. And they ended up just getting back here about 110,000 pounds an hour out and lowering the gear and flaps and running the engines up and just doing that much more damage to airframe issues and engine issues. And that's stuff we haven't even looked at yet. So the numbers I'm showing you are just those for the gear. So there's a lot bigger potential out there once we start digging into this data. And this is not stuff that folks are deliberately doing. It's that they don't know because nobody's collecting the data, and that's what we're trying to get them to.
Sir?
Yep.
Because like struts and tires can be replaced.
Right.
But, and I'm not an aircraft engineer, but maybe like the stress on the frame of the aircraft itself to turn that into lengthening the lifespan of an aircraft?
Absolutely. Yeah, that's the next thing that we're really working on is that in this relationship at the Aircraft Structural Integrity Program office, you know, we wanted their data, and now we're going back to say, okay, so can you guys tell us what this does to the age of the aircraft? And then go to the engine guys at Tinker and say, can you tell us what this does to the age and wear and tear of the engine? Because both those things are going to be big numbers. I think probably bigger than the numbers we're seeing right here. And that helps, you know, helps everybody understand, hey, we have to put some money into collecting the data and behaving a little differently we've behaved in the past. To me, it's a lot like changing the oil in your car. You could have a brand new car, but if you're treating it like a rental car and you don't change the oil, then this stuff's going to wear out a lot quicker than it should.
That just seems like it'd get a lot more higher attention knowing that you could keep X number of planes in a fleet for X more years.
Oh yeah, absolutely. Yeah, so initially we went at it from the fuel perspective. Now we're at it from the here's what it's doing to your readiness perspective. And really the next step is here's what it does to your cost perspective. And so I have that one guy, he's a great guy, he's really smart, but I can only shove so much data down his throat before he goes, stop, I don't have any other, I don't have any more throughput. So, but that's kind of why we're here. We were down in San Luis Obispo. We were talking to some of their ops analysis folks and their computational fluid dynamics folks to kind of talk about this. And we're looking for folks to come with us with ideas and, you know, the ability to help us with some of our analysis, you know, kind of fact checking our analysis to make sure that we're on the right track. Yes, sir.
So is this sort of information and analytics also being applied to inform future purchase decisions, like say with the next generation of aircraft? You mentioned how.
Yes. Well, we're in the process of that too.
Okay.
Yeah. So I'll talk a little bit about that. So, so that's just kind of the tagline for there. Some of you might have seen this. This is kind of the basic. This is a couple of years ago in Al Udeid, which is, you know, at the time, just on average, I could say maybe 50 tankers on the schedule per day. Of those 50 tankers, about 250 air refueling events. And the Defense Innovation Board came to visit. And Eric Schmidt from Google was one of the folks that was visiting. And Eric Schmidt stopped them and said, what is that? You know, because he's an IT guy and he's thinking, that's crazy. And he was right. And they go, yep, you're right. It's crazy. We shouldn't be doing that. Because to me, 19th century technology, especially 50 tankers, a 50 tanker schedule with 250, there's no way that one person's really going to be able to do that very well. They might be able to do it well enough to make it work, but what are the impacts of that when you're actually going to war and you want to optimize your assets? So we heard about this. The program was going to be, it's this whole idea of the Air Force saying, hey, we're going to do more agile software development, and we had initially spent like on the order of hundreds of millions of dollars trying to take the whole Air Operations Center and computerize it, and that failed because of a, I'm told a more waterfall method of delivering software. Give us your requirements. We'll come back in 6 months to a year and give you our product. And every time they came back, it wasn't quite right. And back and forth and back and forth. And at some point, Congress said, hey, you're spending too much money on this. We're not going to let you do this anymore. So the Defense Science Board's idea was, let's go in and let's look at individual pain points in the scheduling process and the execution process of all these missions and see where we can optimize them. So Jigsaw was one of the ones that we're going to do this. We'll stick a Agile software programmer right next to the operators and schedulers, and let's iterate between us back and forth on a weekly basis. I'll watch your challenge. I'll try to code in a solution. I'll come back and address that pain point, and then the next pain point, and then the next pain point, until you get to the point where you have a solution that's much better and much more efficient. So in this case, they started off with, it's going to be a 9-month project, and maybe at 9 months, you know, there is a level of, and this is just human nature and understanding change management, there's a level of resistance for new processes, right? It's not broke. Why are you trying to fix it? And the companies that behaved in that way in the past, Sears, are not around anymore, right? Because they didn't, they were the Amazon of the 20s and 30s, but they never transitioned from that catalog to something that was like what we have today, right? So it's the same type of thing that we need to think about, is that if we're not constantly changing, our adversaries are, and they're going to figure out ways to do things better than we can. So in this case, at 4 months, the schedulers started looking at the guy, so there was like maybe 2 guys working this 12-hour schedule, 8 to 12-hour schedule to produce this. And the other guys are done in 4 hours, and they're going drinking a Pepsi or something. And they're looking at the results, and they're like, oh yeah, we'll adopt it now. So 4 months later, they adopted Jigsaw as opposed to waiting the full 9 months because they realized it was better. But it was still a very manual process. So this one I talk about 19th century. This is kind of glorified 19th century. 20th century is what they developed, which is Jigsaw, which is like, think paper map, electronic map, and now what we want to get it to is Waze, right? They got it to the electronic map, which is something that helps the guy, you know, in, hey, here's an aircraft taking off, and if I go to air refuel here, this is how much fuel I have left before I have to come back home. So we wanted to take them to the Waze function, and at the time they said, we've got so many other requests for software developments that of this type that we're not doing that. So we gave them some of our congressional ad money. They went from this, which is about a 4% increase. This is about a 4%, 3.6% increase in efficiency by getting the computer to help you out and give you some informed decisions of how to get from point A to point B. And what we've done so far is, and you can see this is 180,000 gallons of fuel per week not being used that could be repurposed for other missions in theater that we didn't have the fuel to do with at that time. Less tails, less sorties per day, less manning requirements to do the same mission. The thing that we've developed is called Pythagoras, which is just an algorithm like Waze. The guy punches the button, 20 minutes later it gives him, you know, through multiple different, you know, thousands of different calculations, gives him the optimized solution, allows him to move stuff around to prioritize, and that one takes it from, we're saying it'll get a 10% increase, we think, but the initial tests, the man versus machine tests against this guy who was the most experienced scheduler that they had working Jigsaw, it was 20%. So 20% is getting close to about 1 million gallons a week saved to be used in something else. And you would think that we were doing this everywhere, but we really aren't yet. And so part of our deal is to find initiatives like this, prove them out, and then go back to Air Mobility Command. You know, when you start, you know, quadrupling this number, now all of a sudden they're going, man, I don't need to keep as many in theater there. Or if we have a fight in the Pacific, how much more capability do I have that I wouldn't have had beforehand if I hadn't adopted these type of tools? So our next step is actually, we're working on I don't think it says it here, Magellan, yeah. We're working on a worldwide, they used to, I think it was initially called Pitbull because there's some rapper named Pitbull who's the worldwide rapper, so, but we changed it to Magellan because that was a little more palatable. But the idea is that Magellan's going to do the same type of thing worldwide that Jigsaw does in that theater, and then our idea is that we're going to export that. We're currently trying it out in Korea, but we're going to export it to all of our air operations centers because that's just the 21st century way of doing business, and we need to get there as soon as possible. The other thing we're looking at, and I talked a little bit about the cargo optimization working group, we want to better understand, so if we see that going on with tankers in Air Operations Center, we know similar stuff is happening in the way we deliver cargo, the way we deliver passengers, the way we schedule training missions. So all these type of things are initiatives that we're going along the same line. And then in strategic basing, you know, I've seen strategic basing, we've come a long way in strategic basing decision making, but I've seen strategic basing decisions in the past where we really didn't take into account what the operational effect of the basing move was. Like let's say moving RC-135s from Mildenhall to Lakenheath or Fairford, you know, it's more than just what the ramp space is, how many security forces we have. It's what's the weather like there? How many operational missions can I conduct at Fairford as opposed to Lakenheath? And when we brought that to the attention of the folks doing the basing process, they said, you're right. We need to be looking at this as well. And so we're starting to take that on in other basing decisions, including in the States, because there are some times where we're told you're going to move from here to here, and we really don't have the ability to go, this is the impact from an operational and training perspective. Yep.
So the point then is to gather all that information and provide it to Congress to get their approval?
No, the point is, the point is for us to make better basing decisions. If we're going to go roll out F-35s at certain places, we have to better understand what the limitations on training are there and what that cost is to us. Because when we do these basing presentations, right, to the Secretary, I mean, they're going down to exact dollar amounts for MILCON, exact dollar amounts for personnel, but we're not really going to, well, this is how much it costs us, you know, this is how much different it's going to cost us to operate out of this place, because we're giving her a slew of different potential options of where to go to. She needs to know not only what the MILCON costs are, but what the long-term costs are on readiness and the expenses of readiness, because if you just say, well, there's a range 100 miles away, so we're good, because that fits our strategy of, hey, we want to have every basing action within 100 miles of the nearest range. Well, how saturated is that range? Does it have the right equipment or not? And that part hasn't been sorted out as well as we'd like it to be, because there needs to be a dollar sign against that as well, so that we're making a better informed decision. And when we're told, you know, the leadership wants to move somewhere, we'll either be able to support them with good data that we have to tell Congress eventually what we're doing, but it's just about fact-based presentation of what the costs are, that we're not doing as good as we could now. And we're not doing it partially because aviators don't want to collect, their fuel data. You know, I've had folks tell me, this means you're going to cut my flying hour program, so I'm not going to give you that data. And I take off full and I land empty, so I'm efficient. Think about that. I take off full and I land empty, so I'm efficient. That's been told at the highest levels to me. And so that it's about helping change that culture. In some airframes that may happen a lot, but that doesn't mean that it's the most efficient place to be operating out of, right? All right, I'll go through this a little quicker because I'm taking a lot of time. So other things that we look at, and the reason I was coming from, let's see, we went to Salt Lake City to talk to F-16 folks, and then from there we went into San Luis Obispo to talk to some folks who are doing some ISR stuff for us. We have an interest in understanding new technologies. We've received proposals to do testing on hybrid wing body aircraft, and the reason we're interested in that, when you look at that, like for example, when we war game, Futures Games is one of the war games that we've been involved in. We want to know what the change is from, you know, a traditional war game where we're flying F-35s with the current F-135 engines to the adaptive engine technology that'll give you, you know, in 20 to 30% fuel efficiency, range improvement, you know, as well as other things. So we want to know what the impacts are of that. And then we can start making informed decisions on, and that's really the important part, is making informed decisions on how we spend money on future technologies and how we base and MILCON for the Pacific and for Europe and all that. Having these numbers and having an understanding of the impact of these new technologies will help us make sure that we're not just putting money against something because it gives us more capability in that one airframe. It's really how it affects the whole ecosystem. You know, so right now I could tell you, I don't know for sure how much an F-35 with an adaptive engine is, how much that's going to change the ecosystem as compared to a B-52 that's re-engined. That's what we want to know. so that we can lead turn these decisions, and it works in the same way for all other types of basing decisions as well. So, so that's why we advocate for some of these new technologies, to just better understand them, and then in some cases just kind of push them in the direction by doing studies that show, hey, this is really going to work. You know, why aren't we thinking about this? So we spend a little bit of money on that. These are some of the legacy airframe, work we've done. You can see over here, there's these little fins on the side of this C-17. Those are called microvanes. We went to a company that did some CFD, computational fluid dynamic work on us. This is actually the computational fluid dynamic done on a C-130 with microvanes to figure, you know, much in the way that winglets help with vortices off the wingtips, this stuff helps with the vortice off the tail. And some of these aircraft, like the C-17, they have a ramp sweep that's so much that there's a fair amount of drag that's produced off the tail. And, you know, we wanted to know what the cheapest solution was to fix that. So this company goes in and they actually 3D printed these fins. They're about that long. They used F-22 canopy sealant, glued it to the side of the C-17. We flight tested that plus a bunch of other varieties. And we were trying to get to the point where you can just say, what's the cost to investment ratio? How quickly is the payback? And now can I use some of that congressional ad money through procurement to go back and outfit that fleet? And then what do I do with the savings? Does the big Air Force get to keep it? Or should I keep a little bit so I can go back and put new winglets on it? These winglets were designed in the 1980s, right? I'm pretty sure in our discussions with winglet companies in Seattle that we could do a lot better than that. So, so in this particular case, we saw about for microvanes, about a 1.2% increase in fuel efficiency for something that costs $3 million to install fleet-wide, not just one aircraft, but all the aircraft. So it's a payback ratio on the order of about 3 to 6 months. So that's an easy win. We're looking at similar types of technology in other aircraft, as well as looking at how do we outfit some of our older aircraft. KC-135s don't have winglets. They've never had winglets. We tested winglets on the KC-135s back in the 1970s. And I actually had someone who said he worked at Boeing in the 1980s who said, we checked that in the 80s and it didn't work. And I'm like, oh, okay. Well, you know, the bottom line is a lot of stuff has changed since 1980. A lot of composite technology has changed. A lot of the way we develop winglets has changed. So it's that kind of, you know, just because it didn't work beforehand, my team is really looking at what things are close and what things could, with the right technology, make it to the next level. And then some of it is timing. You know, it's going to be difficult to crack open the wings of KC-135s just to put winglets on them. But if we're going to fly them to 2045 and we're already going to do a service life extension program on them, maybe that's the right time to do it. And in that case, we think about 7 to 8% fuel efficiency savings. So that would be a pretty big win for us if we're able to do that. We've also started to look at just other areas. The computational fluid dynamics not only helps with that, but some of our older airframes like the B-52, we've got so much stuff stacked onto that thing that we think that through some smart computational fluid dynamics that we can identify areas of high drag that can be eliminated by just simple fairings and modifications. Let's see. We've also started looking at turbine engine technology. Turns out that there's some really good coatings these days that allow a compressor blade to maintain its shape for a longer period of time, and I'll show you a little bit about what we do with that in a couple slides, I guess. Where I was down there in San Luis Obispo looking at is these type of technologies. We've got a company in San Luis Obispo, another one in Irvine, California, that are looking at ISR assets that, you know, your typical MQ-9 Predator ISR asset, maybe 24 to 36 hours, something like that. These things are going 4 to 8 days is what we think, right? So just imagine from, you know, when you go back and look at that, those big fuel logistic issues, also from our ISR perspective, we don't have to have national assets staring down on something when we can, you know, use these relatively cheap, I mean, on the order of a couple $1,000,000 for something that can do a mission that right now is you know, when you look at the combatant commanders list of things that is important to them, more ISR is always on the list. So we want to be able to do that. And the reason we think it's important is that what we found is that over the past few years, there hasn't been really much change in process. Maybe 3% in the last 10 years that we've been able to do better processes that result in efficiencies in the way we operate. So that's talking to guys like me, right? Saying, hey, fly better airspeeds, don't dump fuel, you know, look at your fuel loads, that kind of stuff. So maybe 3%. All the rest of it has been in mission substitution, where we're saying, we're flying these type of missions right now with these really thirsty aircraft, and we could substitute it with stuff like that that'll get us with the information that we need at a much lower price from a fuel logistics perspective, and we can use that fuel for other missions that we wouldn't have done otherwise. Okay, so I talked a little bit about compressor blade scanning. So what we've discovered is two things, that there are technologies right now that are being used by the airlines to refurbish engines in a way that can make us can make it much cheaper for us to sustain our engines. So you can think about in certain when you bring an engine into the depot to have it worked on, you typically pull out the blades, they have to be inspected. When we were talking about efficiency with the folks who do the sustainment process, some of their efficiency measures are based off of time from starting to work on this thing to where it's out the door and back in a can with respect to an engine. And what we're trying to do is insert that piece that says, that's your efficiency because you're trying to get engines back in cans and send them back out to the fleet. But for our efficiency is, you know, what's the efficiency of that engine when it's done? Is it just as good as a brand new one? Is it not so as good as a brand new one? What can I do to help you put out a product that is not only as quicker than you could do it before, but using a technology that'll help it last longer and help it produce better fuel efficiency over the long term? So one of the pieces was they're developing technologies now that in the past you used to pull out compressor blades and you'd actually look at them and you'd have to do a dye penetrant and look for cracks and other kinds of damage. And there's a company that actually is developing scanning methods to tell you whether the blade's good or not, to include vibrating it at high speeds, looking at the IR signature of the blade, and that's helping you detect cracks and you know which ones to reject and which ones to keep. Because in some cases they said, we're not doing that anymore because we have it used to be 10 days, needs to be 8 days, so we're throwing away blades instead of re-inspecting certain ones. And those blades are expensive. So if we can get them to use this process, and they're in the process of testing it right now, we think we'll get a lower cost to the way we're producing the engine. Now, the art part of it is that, let's see, do I talk about it in the next slide? Yeah. Our part is not only do we want them to be producing a more efficient engine out the gate, but we also want them to be thinking about coatings that are available now that will make that engine last longer. This is a set of 3 C-130 blades that was tested by the Navy, actually. They had one blade with one coating, one blade without coating, ran the engine, shoved a bunch of sand through the engine intake, and wanted to see what happens. And so from a fuel efficiency perspective, not good, good, right? The second part to that is from a fuel efficiency perspective, if I can laser scan these blades, and this one company came to brief me, they do a laser scan of the measurement geometry of the blade about right there or so. And what they were doing is they were comparing the various different blades they had on that one stage of the turbine. And what they found is that if you tighten up the tolerances of the various blades in that one stage, that you can do a pretty good job of increasing the efficiency of that blade as well, which results in it running lower temperatures, longer life. And they told me about it, and I was a little suspicious. It was like my boss wrote an article that was in the LA Times, and she said, go talk to this company that just sent me a letter about my article. So I went to LA, and they showed me, and I was like, okay, who are your customers? And they said, well, Delta and American Airlines. So we went to Delta, and Delta said, yep, best engines I've tested on test cell, 2 to 3% better. So we're like, okay, so how do we put that process in? So that's where I take this congressional ad money. We go to Tinker, we test it out, and we see how we fit that in. Because 2 to 3% on a KC-135 is a lot of bucks, especially over the long-term life of the engine. And we fly so many heavy aircraft that you can really extend the life of the engine and reduce the operating costs of that particular aircraft. If you're thinking along these lines, which we really haven't thought about in the past, because we were more about, let's get this engine out the can, into the depot, get it fixed, and back in the can into the fleet. Whew, okay, how am I doing on time? All right, so this was the one we were talking about a little earlier, about logistics and wargaming. This is kind of a stoplight chart of where we were before 2018. Again, I was really lucky to get a I've got some great guys. Dan Pike there is one of my guys who helps me out with future operations and helps me go find technologies that are being currently used and integrating them into the way we do business in the Air Force. This was one where we hired a guy from the University of Michigan with a PhD in history and wargaming. And he had worked in OSD. And the idea was this thing called GE-18 is the one major, what we call Title 10 war game that the Air Force holds every 2 years. And what we tasked him to do is, hey, let's figure out how we get the way we war game from the way it's been in the past to something that'll actually help us make investment decisions. So if you can think about a war game like a big, chessboard war game, in the past, there was more, and I don't want to fully characterize this and say, but there was a lot of, we're not looking at energy usage, or if we look at energy usage and we identify that we've ran out of fuel, we're going to continue running the war game to figure out what else we can learn from that one particular war game. We weren't really looking at the cost to base and realistic cost of basing. So when we initially started up this war game, it was like, okay, we're going to put all these units in all these different places in the Pacific, and the epic year is 20, 30 something, I guess. And so what we wanted to do is say, how much does that cost? Is that a realistic thing to be able to do? And it turned out it wasn't. That was in the multi-billion, double-digit billions of dollars to be able to base all aircraft all the places we thought we wanted to base it. How much can we execute MILCON-wise? And let's actually do a realistic laydown of what we think we'll be able to get to by the epic year in order to realistically play out that war game with the initial basing of all of our assets. So it's, instead of putting all your parts on the table and saying, I'm playing all my chess pieces, we said, no, we really got to be realistic about this and actually play the chess pieces accurately. How much are we willing to spend in MILCON? And then with those, and how much can we actually throughput-wise from a contracting perspective spend in MILCON? And then let's make sure that once we've done that, that as we play out the war game, we can get a better appreciation of what those particular bases provide to us with respect to being able to win the war game. And the rest of this stuff, supply, bulk transport, storage, none of that stuff was looked at very well. We did look at the airbase, but I could tell you even at the airbase level, we weren't really looking as well at the amount of fuel that we were using. And then sometimes we'd go, we're out of fuel, let's keep playing. So this thing, Global Engagement 18 and Long Duration Logistics War Game, really did a much better job at starting to look at those other things. And what we found was that a significant number of sorties, and I can't really get into how many, but that lack of POL, lack of fuel, is a major issue in the Pacific. Duh, right? Well, 4 years ago when I had a talk with some of our analysis folks in another office in the Pentagon about better assessing this, because I was actually concerned about the ecosystem piece from a what new stuff are we going to advocate for and put into the system. The words were, hey sir, we're going to run out of bullets before we run out of fuel, so we're not looking at fuel. And now, after having a discussion, we've gotten to the point where we're actually accurately looking at fuel. And now we're starting to see shortfalls in where we're basing, what type of assets we're buying, and that'll help us in the future be able to make what we're talking about, which is good decisions on what stuff we're going to buy based on how it affects the ecosystem for that operational plan. So that's been a good news story. Futures game is really just taking it that much farther, of really looking a lot more accurately at what the impacts are of various scenarios, hybrid wing body, F-35s, or the advanced engines, and other technologies, and tell us, what does that do to us being able to prosecute the game? And a big part of prosecuting the game is understanding that, and somebody told me about this, Dan, were you the one that was telling me about the, a country was looking at us, and they were looking at how our fuel supply chains were, and in their war college, they teach a lot about the the Argentinians and the Falkland War, and how that country's example of the shortfalls in the U.S. was to look at that war and think about what the Argentinians could have done to actually win the Falklands War. And a lot of it was just go after POL. So when we're doing this type of stuff now, Red Team is looking a lot closer at that, because you take out the tanks, then you don't have to take out the runway as quickly. You don't have to take out the hangars as quickly, because you can't get many sorties airborne if you don't have any fuel. Okay. Whew, almost done. And this is the last piece, which is us having an understanding of the fact that we have to do a lot more work within the Air Force because of some of the quotes I made of folks telling me things that I, at the time, in some cases I was like, oh, okay, we run out of bullets before and I feel, oh, I didn't know that. Okay. I'll go back and have my folks look at it. It was that kind of mindset because of us operating in the theater that has been very easy to get fuel. So the fuel has always been there. But in these new scenarios, it's not going to be there. And so we need to be thinking more smartly on how we execute the war games to learn stuff and point us out what we want to invest in, how we're collecting the data and making sure that it's valid and looking at various different options, and how we're investing in new technologies, both in new and legacy aircraft, to make sure that we can not make it a fair fight. Okay. And so that's it. We're going to continue to be, for years to come, burning a lot of fuel. And so my office's focus is how do we get it better? And how do we think about this smartly? And what stuff do we start with first? We're looking at the biggest consumers, but just in general, we've got a long way to go. There's a lot of exciting stuff that we're looking at right now. And what we feel is, though, that the big Air Force is starting to realize through things like Global Engagement 18, that, hey, we need to take this a lot more seriously than we have in the past, because the engagements are going to be significantly different. I'll tell you just on that one last thing, is that we had a discussion with the Navy about, because we're pretty good buds with the Navy OE guys, and they give me a lot of hard time as well for leaving the Navy and going to the Air Force. But our latest thing, and I didn't talk about it here, is that we have, like right down here, there's actually a joint operational energy war game. Because what we discovered is that the amount of time that we spend figuring out our own stuff, that's great and all, but the Air Force doesn't fight the war in the Pacific. It's the combatant commander that fights the war in the Pacific, and the combatant commander has to have the information and understanding of the ecosystem from a joint perspective. And so when we have expectations of the Navy, and they're saying, hey, I'm not sure if I can fuel my own stuff, let alone your stuff, and when they come to us and say, hey, I need 3 tankers a day, and I'm like, well, how much time? Well, 24/7. Well, that's not 3 tankers. That's like 3 tankers times 3 per day, because it's usually an 8-hour vol, so that's like 9 tankers. That means you got 18, you see how it adds? I mean, there are things that we don't appreciate from each other's logistical challenges that this joint OE war game is going to do, hopefully make a good impact on, at least, if nothing else, at the senior leader level, because it's being sponsored by the U.S. Indo-PACOM J4. At the senior leader level, it'll be able to help inform their integrated priority list, so that they're asking the services to get the stuff that we really need to be able to be successful in any engagement in the future. Okay. I think that's it. I like showing this one because this is kind of a Army Air Corps Navy combined operation. You do something like this, and what happens? You have the enemy decide, hey, we're going to beef up our defenses, and maybe we're going to go after Midway sooner than we thought. And then you know what happened in the Battle of Midway. So a small little thing of a handful of aircraft that really didn't do a lot of physical damage to the adversary actually drove a much bigger result for us that thankfully worked out in our favor. So it's about innovation. Okay, I think that's it. All right, did I put you to sleep after dinner or after lunch on a Friday? Yeah.
So I got a couple things for you. As you're also spoken with the Air Force Historian's Office regarding things like the Doolittle raid, where they were downsizing their clothing and pulling weight out of the aircraft. And you look at today, we went to electronic flight books, that pulled 40 to 60 pounds, and threw it on an iPad instead.
Yep.
So that was a huge fuel savings.
Yep.
I just wondered if you talked to the historian's office, if they've come to look at some of the problems we faced in the past and how we could apply it today.
So,
good idea for your service.
yeah, we have some, and we probably need to do more. I'm a little limited in bandwidth. What we have been doing is we initially went to Air Mobility Command, Air Combat Command, Air Force Global Strike Command, and said, hey, we need you guys to do this OE stuff, and I have this Air Force instruction that says you have to do this. And they're like, that's great, but I'm out of Schlitz. I don't have any more people to do this, so it's probably not going to happen. I'm sorry. I'd like to, but it's probably not going to happen. And so we were able to advocate for end-of-year funding. And we actually have representatives now at Air Combat Command, Air Force Global Strike Command, Air Mobility Command, U.S. Indo-PACOM, and PACAF. And the idea is that as we put folks there, that they help us with those historical stories, as well as figuring out ways to help the MAJCOMs develop the culture to appreciate that this is a critical shortfall that we haven't addressed as much as we should. So
my other 2 parts are, one, you did mention about biofuels. I know that was the new hotness 3-4 years
Yep.
ago, and the Navy was in partnership with that.
Yep.
I know we didn't go to full fleet in a biofuel mentality, so
Yeah.
if you just had an update on that. And then the
Sure.
second part
Yep.
Hawaii, and my numbers may be off, but it was like a 10% savings in, like 10% increase in speed and 6%.
Man, that tells you my Stratcom people are doing their job, because that's exactly,
Yeah, on AFML server, they were talking about they flew faster, and as a result,
Yep.
they had a 10% increase in speed, but a 6% savings in fuel costs. I just wondered if that has expanded at all to any other airframe for testing.
It has. So I just visited the RSAG, Air Refueling Systems Advisory Group, I think it was, and we talked about that a little bit. So back to the first one was a discussion of biofuels. Okay, yeah. So
That started moving towards.
yeah, so from the Air Force perspective, we're not a producer of fuel. We rely on Defense Logistics Agency to give us our fuel anywhere in the world. So they work that for us. So what we do, I should have said that. That's more of a Austin Powers things. What we've done in the past is developed a group and a regular method for tracking fuel prices to include biofuels, alternate fuel processes. And we've developed a group and a policy letter that talks about how often we look at it quarterly, right? So the problem is that in most places it's not financially competitive right now. I mean, they're doing some neat stuff. I've been to Alt Air in California, which makes jet fuel out of beef tallow, out of beef fat. And so we look at making sure that the certified processes that are out there through ASTM are ones that are compatible with our aircraft. So in the past, we've tested all of our aircraft on HEFA and Fischer-Tropsch. So we've tested on the two predominant processes right now. We've done some alcohol to jet, which is the third process. So we know, our thing is you better know that our aircraft work on those processes when we go somewhere else and we have to grab fuel that's being done in that manner, so that it's compatible, so it doesn't affect our filters or the way. So that's kind of where we're at. We look at it. I've been to Altair. I've been to some other companies. I've had folks come and talk to me about it. We're tracking the price. Once it becomes financially, good, we're gonna go after it. But we want to be aware of what's going on, so we don't want to get surprised, especially if something's going on in a certain part of the world where we think we might operate out of. We want to make sure that that's somewhere that we can. The second part of your question was talking about air refueling speeds. Yeah, so what happened is that I dug up this briefing from like 2014, and I went to my guys and I said, hey, did we ever do anything with this? This was like an Air Mobility Command guy, and I actually owe him a beer because he had done the initial study on what was going on and what he thought he could do to change it. And so we actually, my deputy went out to Elmendorf, and we had guys from my office as part of that demonstration. We had to make sure we call it a demonstration, not a test. So they did a demonstration, and sure enough, so what it turns out is that 5th gen fighters do much better from an efficiency perspective if they fly faster. So from a helicopter mindset, we call it bucket airspeed or max range in a jet. 5th gen fighter max range is about 350 knots. And so they were flying, and in their regs, it said 305 knots was the standard speed that F-22 is going to do air refueling at. And we asked them for all their, what we call coronets, or their cross-Pacific and cross-Atlantic missions. Hey, can we try this one, and we'll come back to you and tell you what the advantages are. We measured it. We got about 6 to 7% on the fuel efficiency, and about a 10%. They got their 10% quicker because they flew 10% faster, which is good when you realize that a 5th gen fighter like a F-22 is about $40,000 an hour. So that's 1 hour, that you're saving that doesn't have to go to depot that much sooner. And so we got ACC to say, yep. As a matter of fact, General Holmes, commander of ACC, was like, go faster, lose less fuel, less time on my aircraft. Absolutely, we're going to do it. So they did. We've already got them to agree to do it on the F-22s and the F-35s, and that's in the regs right now. So here's your proposed airspeed is 335, and then we've asked for them to look at F-15Es because they have conformal tanks, so they might get something out of it. Some of the other airframe we know like F-16s probably won't work like it did. So yes, but that goes back to this is the way we've always done it. Nobody's really asked me to do it any differently, and nobody measured what the differences are. And for us, the big piece is not as much the fuel savings, but the aircraft hour savings, which is comes at a pretty costly price when you're thinking that I think last year 5th gen fighters did like 300 coronets, and we do like 1,000 aircraft or 1,200 aircraft flew by Coronet last year. So that's a lot of aircraft. So there's a lot of potential savings and operational costs that could be repurposed somewhere else. Yes?
Is there any downfall on the efficiency of the tanker?
There was a slight downfall, but it was like maybe, if you look at the whole group, it was like 1%. So the fighters consumed so much more than that, that it was really almost negligible. I think it was like, we said 570 pounds of extra fuel if they flew a little bit faster. And what we found is that we asked, this was KC-10s, we asked, hey, can we do it in KC-135s? Yep, we can. How about KC-46s? Did they flight test for that? And we got a long pause. And we said, hey, can you guys put that in your flight test? Because really, we need to be thinking about how do we certify these aircraft to air refuel at a higher speed than they're currently doing right now. And so if your boom is limited, or if you've only flight tested the boom to 325 knots, then you're really kind of losing out. So.
Has there been any work with the Navy?
Yes, so we went to our OE counterparts in the Navy and said, hey, you guys need to think about this because Cobham, I think, is the company that does the baskets, right? And they've told us that they've developed baskets that can go faster. And not too long ago, we read an article about a Marine Corps general being pretty upset that it took them so many legs. It was so difficult to get F-35s from California to Okinawa that we're pretty sure that same type of thought process would work with them. But we've given them the idea. We talked about it at RSAG. But absolutely, there's no doubt in my mind that you could get that basket to fly quicker because the guys who make it, I don't know if we've tested it to those levels, but the baskets, I guess, are now, I used to remember them all just sitting like this. Some of the newer ones will actually contract so you can fly them at faster speeds, so it should be doable. Yep. Any other questions? Yeah. Well, yeah.
How much are you working with our coalition partners on helping fund like new gadgets like flight data recorders? I say this because I'm a rivet joint guy, so thank you for your part in saving Mildenhall. But
yep.
the RAF has, well, I mean, I know the numbers just like you do, so
yeah.
it doesn't make any sense to go to those places.
Yeah.
So how much, because the RAF is spending a ton of money upgrading the flight deck stuff for us.
Yeah.
That we would never have gotten otherwise.
Right. So, like the microvane stuff that I showed you is actually going to be, I think, tested, long-term tested by the Canadian Air Force because we still haven't got our program office to agree to do that until we've done some testing. And we've done quite a bit of testing on our side. And you know what? At some point, you got to start saying, hey, we have computational fluid dynamics. We have all these things that we didn't have in the past. How can we start doing a better job of using 21st century technologies to advance things that don't have to be done by the old process, especially things as innocuous as a microvane. But can you ask me the rest of your question? Because I'm
just how much are you working with coalition
yeah.
to help fund and then like for ideas as well?
Yeah, so the ideas part, so we visit NATO, and that's one of the main ways we've been doing it. We have discovered that, from a flight data collection perspective, that most of our partners are much better at it than us. If you look at the C-17s that are bought by all the foreign partners, they have the addition to the DAS-11 flight data recorder that we don't have right now. And so, part of my initiative to work through this is actually to point to the fact that, was it Nigeria? Why does Nigeria have microvanes on their C-130s and we don't? Why do all of our coalition partners have flight data recorders for all their heavy jets and we don't? But that's probably the extent of it right now. We do, so we've been doing a little bit of work with Canada on the microvanes, and they've shown interest both in Canada and Australia and the UK. And so the flight data piece has been a little bit tougher because most of our partners collect all that stuff already, and we're trying to go, why aren't we doing that? Like on the F-16 side, really? 95% of F-16s don't have good flight data that maintenance folks can use. They have structural integrity data, that's a separate recorder, but the actual flight data is like limited to 15 to 30 minutes. So there's a little ways to go, and we use our NATO contacts in my visits to Lithuania, and I'm going to be going out to NATO headquarters here at the end of the year to have that discussion because they also have some pretty good flight scheduling stuff that they're already using that we want to see if we can leverage. So we do, but we're getting there.
Sir, on one of your slides, it showed, I think it was a C-130, and it said something like it had 2 LNG tanks to it, and it started talking about where there was tubing going around it.
Yeah. So we have done some, what we're seeing is that there are some companies that are actually investing in LNG as a possible alternate source to aviation fuel. And so we just want to understand that better. There's a pretty major LNG refinery going in. Where is it, Dan? Yeah. So this again is something that we want to better understand what's been done. GE is doing some work on LNG. We want to understand what's been done and what the potential capability improvements are for us, or if nothing else, the flexibility that we could use in certain airframes. So that's really, and afterwards, Mr. Pike can give you a lot more information on that because he's really been the one that's been helping me look at that. So, yes.
So we see a lot in the news that Boeing is bending over backwards for the 737
Yep.
with Airbus.
Yeah.
But the C-17 is still having 1980s technology.
Yeah.
Is there a way to push Boeing to put some of these innovations on our aircraft so that we don't have to do it all ourselves?
Yeah, so what we found is that in the past, the requirements were whatever we asked for. The reason the KC-46 doesn't have winglets, there's a lot of reasons why, but if we're not asking for stuff, then they're not going to do it, right? And so we've been having this discussion about understanding it better and then coming back to them. So we have spent some time with aviation partners, Boeing, to understand winglet design, and they have shown some interest in certain technologies like microvanes. And so yes, but in the past it's been what's the requirement? When I'd had programming folks would say, show me the requirement for fuel efficiency, because there is none in these weapon systems. It's like, give me this range and we're good. And so we go back to, let's go on the classified side and look at the Wargaming results, and then we can talk about what the requirement is. So it's really, if you're not collecting the data, then you can't advocate for why it makes more sense to put something that's going to get you 7% more efficiency. It would make sense, right? And there are things that we do that are not a business case, that are more related to being able to execute certain O plans. We're starting to get that way in being able to advocate for our technologies, but it's a culture change. It doesn't happen overnight. I joke with my folks that I saw this cheesy Tom Selleck movie back in the 1980s, and he said the oxen is slow, but the earth is patient. And that's sometimes we have to think that way, that we're going to keep pushing and keep plowing the earth until we get more folks adopting this thought that we have to consider the whole ecosystem and what the requirements are to the whole ecosystem. So, all right, does that help?
You had a question right here?
Yes. Hi.
Mine's more practical.
Okay.
Question, I think.
Yep.
So since we're all going to different bases and different MAGCOMs, if we run into opportunities where we identify a problem or an efficiency in how the Air Force does things, which I'm sure eventually we all will at some point.
Yep.
Or say our airman comes up with a brilliant and innovative idea about how to fix something that makes the Air Force better, the Air Force wide.
Yep.
Who do we contact to, one, get an assistance in order to address those issues, or say just pass a good idea around?
Right. So there is A2A, which is a process where you send a suggestion to the big Air Force. We're happy to take your suggestion, though, because I don't have enough tentacles to know everything that's going on. So if you have an idea, we're happy to look at it and see if we can assist with it. Because like I said, we do have congressional ad money that we use to go after programs. One of the things that we're doing at Air Mobility Command in the tanker TACC is they showed us a process where the process is spreadsheets and phone calls. And we're like, that's crazy. And they're like, yep, you're right, but we don't have the money to fix this. And so we've been collaborating with them. And part of that is getting the major command to kind of recognize that Agile software development to fix pain points is something that they can do. That it's not something that they have to ship out and wait for a product 3 years later. So my office is a way to go, and the other office is, within the Air Force, there is actually I think it's called, is it A2A, Airman 2? Yeah, that's how much.
Does your last slide have I think it has our website on it.
I think it does, yeah. Yeah, maybe not.
So
Yep.
that's a great spot right there. Either Twitter, Facebook, or
Yeah, we've actually got a contact us line off of that website. So any of those ways, afterwards you can tell me what it is, and I'll hand you my card, and you can send me a direct email, because I'm more than happy to take your suggestions. Like I said, 100% sure we don't have it 100% right, so we're looking for help. Yep.
One of the challenges I see with this, and I'm trying to figure out how to cap this together, is this is very good and effective at taking those large fleets, large group of inventories, and hey, we're going to change this overall process. But then what it becomes is then when you're a small fleet that more needs, you have to have gas just regardless. You're landing heavy just always. But now you have that same mindset of, no, you will not take off, you don't ferry fuel, don't take off with the extra 1,000 pounds of gas, don't take off the extra, because every 1,000 pounds is 10 more minutes of time overhead or something else you can do. So you have this bleed down of good ideas in the large fleet that then start getting enforced onto other parts of the
Yeah,
business.
I know what
So
you're saying.
contracting kind of capability in some
Yep.
ways.
Yep.
How do you kind of see that line? So like getting the benefits without it starting to become its own drag, I guess.
Yeah, yeah, it's tough, but that's where we look to the MAJCOMs. Their main thing is readiness, right? So when we showed this heavy landing weight thing, they acknowledged that a lot of that extra weight doesn't need to be there. That's just something that they've been doing over and over and over again. You're right. You need to have mission flexibility. And in some of our, like that algorithm in Al-Udeid, part of that algorithm gives us more flexibility because you can have more tankers that are maybe on alert or airborne spares that you wouldn't have had beforehand because you just didn't have the right amount of tankers. So it's a balance. You know, as a former operator, I know what you're talking about. Where I need to have that slop, but right now it's like nobody's looking at it. So the slop is so excessive that it, in some cases, is hurting us just getting aircraft ready for the next day's flight schedule. So, all right, you gonna pull a hook? Get out of here, Guerrero. I've had enough of you.
Thank you, Mr. Guerrero.
All right, thanks.